Hello everyone, today we are going to talk about merge sort as another example of divide and conquer that has the nice property that in worst case its complexity is big O of n log n. This algorithm is called as merge sort. Let's see how the complexity will be big O of n log n through an example. We'll take the example and we'll explain you the pseudocode of merge sort also. Now assume the list of n where divide and conquer is having a constraint. When you have n equal to 1, then you cannot apply divide and conquer, that you cannot divide this main problem into sub problems as it is having only 1. When when value is greater than 1, then we will be going to divide the problem into sublisters and recursively we'll be going to solve this sub problems. This is what the idea of divide and conquer. Now we'll be going to apply this divide and conquer on merge sort. So merge sort is what? It is one of the sorting algorithm where the list is not in sorted fashion, but we will be performing merge sort algorithm to get into sorted fashion. Now assume that you have a list of 1 to n. Now for the convenience I am considering n value is 10. That means A1 to 10. Now how merge sort will work is, we'll be going to divide this algorithm, we'll be going to divide this list into two halves. That means if A is having n elements, the two halves are what? A from 1 to A of n by 2 is one subproblem. A of n by 2 plus 1 to A of n is the other subproblem. Till you got number of problem is 1, you will apply the same algorithm, same function recursively. This is what merge sort ideology. Now here two things are required. One is to divide the problem into subproblems till you get 1. The other is what? Combine the solutions. Right? Now we'll take some example which is recursive tree. Now assume that I have 1 to n where my n value is 10. That means this will get divided into how? On basis of what will divide? On basis of mid value, that low value, h value, mid value. Low value is 1, h value is 10, 1 plus 10 by 2, where it is 11 by 2, floor the value, it is 5. So 1 to 5 is one subproblem, 6 to 5 is the other subproblem. Again divide into subproblems. Again low is 1, high is 5, 1 plus 5 by 2, 6 by 2, 3. That means A1 to 3 is one subproblem, A4 to 5 is the other subproblem. A6 to 8 is one subproblem, A9 to 10 is the other subproblem. The same. A1 to 2, A3, A4, A5. This also A6, 7, A8, A9, A10. Now, so till n value is greater 1. So I can divide this into two sublisters, two subproblem, A1, A2, A3, 4, 5. You cannot divide as it is having single element, 4, 5 single. Now here also you can divide, A6 is the 1, A7 is 1. So this is what recursive tree structure of merge sort for a given list of 10 elements. Now this is what dividing the problem into sub problems. How merging will happen? Assume that I have here 3 elements which are 3, 5, 6. These are not into sorted manner. Acha, these are into sorted manner. Now take this 5, 3, 6. Now these are not into sorted manner. Now I am dividing this. Now 5 comma 3 will be here in division and 6 will be here. 5 will be here, 3 will be here, 6 will be there. Now how we will be going to combine the solution? We will be going to consider this as H index, this as J index. Now we'll compare H versus J. So when I compare H versus J, now I am taking some subarray which is some B subarray. Now when I compare H versus J, whichever is smaller, that will be fallen into this. That means I'll get here 3 and the other element as it is I'll write as 5. So now 3 comma 5 are sorted and it will be given over here. So 6 is you have, right? Now the sorting will be done in between 3 comma 5 and 6. Again this 3 comma 5 will be treated as H index, H plus 1 index, and 6 is treated as J index. So comparison will be in between H and J. So which seems to be smaller? 3 is smaller. So we'll take some subarray. Now this is B array. Now whichever is smaller, that will fall into subarray, which is 3. Now this is into subarray. Now H will get incremented by 1, which is H plus 1. Now it is 5. Now the comparison will be in between 5 and 6. So which is smaller? 5 is smaller. The other element will get written as it is. So this is what combining the solution. Likewise, you will get here also one sublist. Likewise, you will get one sublist, one sublist. Now again comparison will be starts in between H and J index. These two. And you will get final solution. He will get one solution. Now we will combine this solution. So this is what merge sort. Finally, we will be going to do two things over here. The one is how merge sort will be performed, how merging will be performed. These are the two things what we have to look for. Now let's write the merge sort algorithm. The merge sort algorithm is what? So I am taking a function of merge sort where my function will take the parameters of two low comma high parameters. Now if low is less than high, that means I don't have a single problem. My n value is not 1, it is greater 1. So find out the middle element to make your problem into subproblems. Low plus high by 2. Now solve the subproblems, that is merge sort, divide the list into halves. Now call the function recursively. Low to mid is one function and merge sort mid plus 1 to high, that is the other function. Now this is what dividing the problem. Now combine the solution with the merge function. Merge low comma mid comma high. Now this is what our merge function. Now let's understand how merge function will be performs its job. Now let's write merge function algorithm. So now merge function will be going to take the parameters which are low comma mid comma high. Now H is equal to low, J is equal to mid plus 1. Now this is important loop. While H less than or equal to mid, double end, J less than or equal to high. So I am considering the two sublists. Now I am comparing it. A of H less than or is equal to A of J. That means I am taking two sublists, right? Just now we were seen in the last example, recursive tree example. So there we were taken two lists, right? 3, 6 and 5. So in these two sublists, I am taking this as H index and J index. So I am comparing these two elements. Now when I compare these two elements, which element will get fall into the another array? That is B of I is equal to A of H. So whichever element E seems to be lesser, that will place into the new array. Now H is equal to H plus 1. Now else part. If it is not true, now B of I will be, J of J will get placed into B of I. Now the same J value will get increased by 1. So this thing will get repeated until your values are finished. Now the important thing is what? H less than or equal to mid is one of the case. The other case is what? H greater than mid. So in that case, when H value is go beyond of the mid, H is greater than the mid, the values has to be placed directly. That means whichever values are left over in the set, that values we will be writing down till you meet H. That B of I is equal to A of K. Now I is equal to I plus 1. If not for K is equal to H2 mid, do B of I is equal to A of K, I is equal to I plus 1. And this thing will be repeated. For K is equal to low to high, do A of K is equal to B of K. So this condition is when H is greater than the mid. Then you have to take the elements, right? So there are times when you will take the values of 1, 2 over here, and these are the list of many. It can happen, right, in the combining solution. Now these two elements will get completed over here and these will get left. So you cannot compare with this array. At that time you have to write directly these elements. But that is the reason H greater than mid case will get useful. Now we'll see the analysis part. If the time for merging operation is proportional to n, then the computing time for merge sort is described by the recurrence relation. T of n is equal to A when n equal to 1 and A is a constant. When n greater than 1, it is T of 2 Tn by 2 plus Cn, where C is a constant. Now dividing the list into two parts, right? Now this can be occurred recursively. So where n is a power of 2, that means n is equal to 2 power k. We can solve the equation by successive substitutions. That substitutions are, now T of n is equal to 2Tn by 2 plus Cn. Now T of n by 2 is what? Apply in the place of n by 2 by 2, n square, 2 square, that is of 4 plus Cn by 2 plus Cn. So apply in the place of n by 2 we are substituting in the place of n. So now you will get this, right? Now multiply with 2. Now 2 into 2 4, 4Tn by 4. 2 will get cancelled, Cn plus Cn you will get 2Cn. Now again T of n by 4 is equal to 4 into T of n by 8 plus Cn by 4 plus 2Cn. Now this time you will get 8 of T, 8Tn by 8 plus 3Cn. Now assume that 2 power k T power 1, T of 1 plus k Cn. Now so I am taking a constant value. Now this thing I can write as what? 2 cube, and this is what? 3. So here 2 power k I can assume, right? 2 power k T of 1. Now what is this T of 1? When I am writing this n by 8 in recursive function, in recursive algorithms, n by 8 value will meet to 1. So that is of T of 1 plus k Cn. Now n equal to 2 power k, right? So I am taking here n. T power 1 complexity in the recurrence relation is A plus Cn log n, as I am taking k equal to, if I apply n equal to 2 power k both the side logarithm, I will get n log n or log n. So Cn is already there, I am taking in the place of k, I am taking log n. So it is easy to see that if 2 power k less than n less than or equal to 2 power k plus 1, then T of n less than or equal to T of 2 power k plus 1, which means T of n is equal to big O of n log n. This is the worst and average time complexity of merge sort. Thank you all.